Hey guys, so in this lesson we're going to be going through 3.3 surface area. You guys are familiar with surface area from last year and just regular life. So if we're talking about surface area, we're basically talking about the area of the surface of an object or the area on the outside of an object. So the area on the surface or outside of a 3D object. So when we're talking about just the area of a rectangle, that's not really a surface area because it's not 3D. Same thing as a triangle, circle. But as soon as we get to a cylinder or a cone, that is going to be a 3D object, and that is going to be surface area. So there's different surfaces that we have to look at. Okay, so for a cylinder, there's a surface of the side. So the side of a cylinder has a surface, and that is this right here. So L stands for lateral and just means side. So that is the side of the cylinder. This right here, AB, is the base of a cylinder. But you'll notice that the area of the base of a cylinder is just a circle. The area of a circle is pi r squared. I only have one surface here. So if I were to find the surface of this whole cylinder, I would have to times this by 2 because I have a circle on the bottom and I have a circle on the top. Okay, so for a whole cylinder, my surface area would be 2 pi r times h and then plus 2 times pi r squared. Okay, and remember, if you don't like using the r squared button in your calculator, you could always just do r times r. Okay, for a cone, this AL, so this is the area of the side of the cone again, and AB is the base. So the base of a cone is a circle, which is why it's just pi r squared. Don't get your circle area confused with circumference. So it's pi r squared for area. So a cannery has redesigned the size of a can for its canned salmon. The diameter of the new can is 4 inches and its height is 5.5 inches. How much tin will be needed to construct one can? So when we're thinking about a can, they are usually in the shape of a cylinder. And there's a hint in here that this is going to be a cylinder because it talks about diameter. Okay, so what has diameter? Well, a cylinder has diameter. And you go, and you don't usually see cone-shaped cans. That would be a pain. Okay, so I have my cylinder. So I like to draw a picture first. Okay, so the diameter of the can is 4 inches. Okay, and its height is 5.5 inches. Now, my formulas for the surface area of a cylinder to see how much tin is going to go around this can is, if I'm finding my side, it is 2 times pi times r times h. Okay, so I have a height, but I do not have a radius because I was given diameter. So remember, your radius is just half of your diameter if you're given diameter. So we can find radius very easily by dividing our diameter by 2, and we get our radius is 2 inches. Okay, so my side is going to be 2 times pi times r times h. Now substituting in, so I have 2 and pi is just a number. Remember, it's a 3.14 blah, blah, blah. And then radius. So my radius is 2. So where I see my r, I'm going to put 2 inches in there. Okay, and for my height, that is 5.5. So 5.5. So what I'm going to do is 2 times pi times 2 times 5.5. And we'll see what we get. So in your calculator, you should have 69.1150, so on and so forth. And that will now be inches squared. So I had inches times inches, I get inches squared. Okay, so I am not only just going to have the side though, I do need the top and the bottom, otherwise my salmon is just going to fall right out. That would make no sense for a can. So I need my top and bottom. Okay, and my top and bottom is going to be pi r squared, and I need 2 of them. So I need 2 times pi r squared. Okay, so substituting my radius in there, so I'll do 2 times pi, then my radius is 2, and I have to make sure I square that. Okay, so putting that into your calculator, you should get 25.132, so on and so forth, inches squared. Okay, now to figure out my total surface area, it'll be my side plus my top plus my bottom. So it'll be this number plus this one. So adding those two up, you should get 94.2477 inches squared. And just rounding to either 1 or 2 decimal places doesn't matter to me. Let's do 2. So then we got a nice 0.25 there. Okay, so rounding over, I get 94.25, 94 and a quarter square inches of tin that I'm going to need for that can. Okay. And for our next and last example, we have Sarah, who's been hired to paint the exterior of a storage bin. The bin is a rectangular prism, and it measures 2.3 by 4.4 by 2.8 yards. And we want to find out what the surface area of the bin is going to be. So she needs to know the surface area, so she needs to know how much paint that she's going to buy. Okay. So, rectangular storage bin. Here I have a rectangular bin, and I could show that it is 3-dimensional by going like that, or I could even just cheat and put this in. That looks a lot nicer, which you cannot do. Haha. Okay, so here I have my rectangular storage bin. So any rectangular prism, you're going to have 6 sides. So you'll have a front and a back that are the same area, a top and a bottom that are the same area, and a left side and a right side that will be the same area. So we only really have to figure out 3 areas. Okay, so let's put our dimensions in. So we have a 2.3 yards. So I'm going to say it's like 2.3 yards deep. And 4.4 yards. I'm going to say it's 4.4 yards long here. And let's say 2.8 yards high. Okay, so you should always have one of these 3 dimensions labeled. I will usually do it like this. So starting here, next one, not labeling any of these. So I like to keep them in the same spot so I don't confuse myself. Okay, so let's find the front and back first. It doesn't matter which you find first or second or third, but I like starting with the front and back. So front and back. So I will always draw a rectangle, and I will put what my dimensions are for my front and back. So for the front and back sides, it is 4.4 yards long and 2.8 yards high. Okay, and finding the area of a rectangle, I will do length times width. So my 4.4 times my 2.8. And calculate. Yes. 1232. And we have a yards times another yards, so yards squared. Now, this is finding the area of one of my sides, but I know I have 2 of them. So times that number by 2, and you get 24.64 yards squared. Okay, next, let's do top and bottom. So doing our top and bottom, drawing a rectangle, and top and bottom, well, let's look at the bottom here. It's 4.4 yards long and 2.3 yards down. Okay, so my area is going to be 4.4 by 2.3. So calculating, you get 10.12 yards squared. But I know I have two of those sides. So I have the top and the bottom. So 10.12 times 2, and you get 20.24 yards squared. Last, we have our left and right sides. Oof, lightning. Okay, so for our left and right sides, it is 2.8 high and 2.3 across. So to find my area, 2.3 times 2.8. Oh, sorry, my writing's so bad, you guys. And you get 6.44. And now you have two of them, so times by 2, and you get 12.88 yards squared. Now to find the surface area of your whole object, add all your sides up, and you should get 57.76 yards squared. .76 yards squared is the surface area of that bin. Okay, I am really sorry for my writing. All right, so you can do your 3.3 surface area assignment, and you're good to go.